Good afternoon, everyone. Peter Adriaens. I'm in the College of Engineering School for Environmental Sustainability. Was at the Ross School of Business for about a decade, as well as in and out of the university working with various different asset managers. So this is a very different kind of topic or application, shall we say. It's also an application where practitioners are very risk averse to the use of AI. In finance, basically regressions still rule, and so we'll talk about, I guess, how we try to overcome some of these risks and how we got that all started well before, I guess, GPT actually even came out. So I'm going to be talking about an AI model designed to predict and mitigate financial risk from water scarcity in global corporate facilities. That's a mouthful, but it started really with your pension fund coming to us, i.e. TIAA. So TIAA said, look, what we're seeing among our holdings, such as a Bayer or a TSMC, is that their costs of operations are significantly increasing, and they're increasing because of low levels of for example, here the Rhine River, or water that needs to get trucked in to manufacture semiconductors in Taiwan. So this spreads itself across all companies and most facilities that are part of the holdings in your pension fund and that are holdings by insurance risk managers. There's about 7.3 trillion that is impacted by water risks resulting from climate change, and other assets under management such as stocks and whatnot are all exposed to that risk. And TIA said, look, can we quantify that? Can we figure out how we can diversify away from excess risks that we cannot otherwise manage? We give you one. Okay, here's, I guess it's got over animated, but just some examples here on both supply chain interruptions, of course, drought impacts, and then impacts, in particular, now that we're talking about AI, your data centers as well. We talk a lot about the power and the power needs in data centers, but the water risk in data centers is a huge problem as well. Testify here to a very un-AI query that I got about 3 years ago from AWS through my company, which still has an info@equariusrisk.com, and AWS actually contacted me through that. Go figure. Sometimes the old way still works. So we're now working with them to try to tease out sort of where the counterparty risks are of contracting with water utilities to actually be able to cool their data centers. Here's a great example. This is the Florida Retirement System Trust Fund. So what trust funds and pension funds are increasingly starting to do is heat map the risks, and this is specifically water, not even climate, how water is impacting the operations, the costs, the growth, the valuations of the assets in their portfolios. I show it here at industry level. So we have healthcare and IT and industrials and all of that. And of course, underneath the layer underneath that is individual companies. And as you're seeing, the heat map of these holdings is flashing red. And they're figuring out how to get rid of that stuff. So around that time, and everybody probably recognizes this name by now, the Financial Stability Board in Switzerland said, okay, we've got to get ahead of this, because all these pension funds are essentially worldwide, sovereign wealth funds, major investment banks are actually exposed to risks that have actually never been measured, have never been quantified, or are quantified inappropriately and at the wrong level. And that was a big part of why TAA came to us. So Carney, when he was still the former chair of the Financial Stability Board, said, look, we have to come up with some sort of a way to force companies and investors to disclose their climate-related financial disclosures. Financially, not just say a lot of water, not a lot of water, high carbon, low carbon, but what is the impact on your earnings? What's the impact on your assets? Are they going to get stranded? Are you going to have a lot of leftover facilities that are actually not producing? So all these kinds of issues. So currently that's everywhere but in the US, now integrated into corporate accounting. It's really tangible. So back to AWS. So we got this call, and that specifically had to do with the Jackson, Mississippi a little bit more, I guess, geography here, U.S. geography. Jackson, Mississippi facility built over here, which is exemplary. Of course, it's one that they're still building. It is a data center facility. It's a campus. A campus of data centers means 16 data center buildings. So one campus is 16 data center buildings. 16 data center buildings need to actually figure out where they're going to get the water to cool all these data centers. And whether that water, that counterparty risk is reliable or not. The call to us actually was, there is so much demand on data centers now, we have to start placing them outside of the US, outside of Japan, outside of Europe, into developing economies. So there is a sector within AWS that is emerging data center line of business. So what happens when we put them in Chile, we put them in Morocco, we put them in all sorts of South Africa? What are our risks when we put these data centers over there? So, well, what keeps them awake? Well, the water risk mitigation and investment decisions for sites. They need to hedge that risk. Hedging that risk means a ton of money that they have to invest themselves in case something goes wrong. Assessing counterparty risk for future siting and opportunity cost impact on earnings and share price. Now, so this is directly from the horse's mouth, Hector Casablanca at AWS Water Projects. Now, you multiply this back to the pension funds. Here's the S&P 500. 504 companies, roughly 250,000 facilities globally, each of which have water risks. These are supply chain water risks. These are drought water risks, flood water risks, everything else like that. We need to quantify what that risk is because these companies have to manage their portfolios. And that is really all part of getting out of the red and into the black. So it is a strategic business challenge, and we were asked to sort of start addressing that. The story, I guess, that I'm telling you very briefly here is sort of part of what our AI journey was, right? It's that context initially of, look, climate and particularly the water and across all these pension funds, remember the Florida pension fund, is starting to destabilize the capital markets and impacting your retirement income from corporate risk exposures. The question was, though, what is the actual question? What is the problem that the AI model needs to solve for? Because you say destabilizing stocks, I mean, you can go in 100,000 different directions. Again, talking to a lot of folks so initially we presented some data in New York at a bunch of different asset management conferences. They said, we have this. They said, okay, what are you going to tell each of the companies that we hold on what they should do to actually manage their risk? So back to AWS. AWS said, look, our biggest problem is something that we're guarding almost as much as we're guarding the operations of our actual data center, is our water purchase contract. That's sort of kind of caught me out of left field. So the water purchase contract that all these companies at each location need to negotiate to actually manage that risk, we need to figure out in that question is, what is the counterparty financial risk management strategy? What's the big idea? What are the actionable insights to start automating and understanding what the information what the risk management in that water purchase contract needs to be? So it's always a negotiation position between an asset manager and a water utility. Strategy, language models. Water contracts exist. We need to understand the terms. We need to link the terms with the financial risks associated with all these different companies. And then we need to figure out how we're going to be pricing and setting the terms for these contracts. Right? So ultimately, we need to bring it down to facility level. When Mitsubishi comes to me, they have 750 facilities globally. There is not one strategy. They're asking essentially for 750 different strategies. So the challenge is that, I guess, sort of kind of putting it into our sort of software stack, is that we need to integrate and corporate financial and market data and climate data and some of their own disclosures that are on Bloomberg. Actually, Bloomberg in the next couple of days is hosting a water AI platform that they're starting to set up, I guess, around equities, integrate all of that and spit something out that they can make useful. In simple terms, it's this. The AI really serves as the risk hedge manager in between whomever the water provider is, the water utility globally, wherever that is, and whatever the company is. Data center, chemical facility, real estate asset, whatever it might be, right? So how do we inform what that contract must look like? And it's typically about 25, 30, 40 pages long with all sorts of covenants in it and all sorts of triggers for when certain covenants prevail. So we're getting involved in information theory ruling. We heard about that earlier. For automated extraction of common contract language, optimization of facility-level counterparty risk hedging, and setting up an interface for queries, because ultimately it sort of starts with the query. Most of the people that we start talking to at companies initially are not people that look at data. They're not people that use AI models in the sense of asking a question, getting something back. These are heads of supply chains. These are CFOs. These are asset managers. These are not the financial analysts that are multiple layers behind some firewall. So data ingestion layer, I just already went through that. So in our queryable architecture, we have hydrological data sets, climate data sets, corporate water usage and demand data sets, corporate financial data sets, supply chain network data, regulatory frameworks. Because we can optimize all we want, but if the regulatory framework caps the allocation, you're still stuck. Then we have to say, look, there is no option here for you. The option is this cap. After that, you got to invest in your own capital infrastructure. Multiple modeling layers. And remember, when we got started, there was no GPT to start searching a lot of this. So we still, and also because I'm out of the finance space, finance is a lot of, as I said, regression and regression plus. So we sort of had to carefully bring them on board. Initially, TIA demanded weekly update meetings. Man, many of us are researchers. There's only so much one can do in a week. But what the week helped us do is develop a common understanding, common language, make them comfortable with AI, with learning models, with different constraint models and whatnot to sort of bring them into that space. So ultimately, we want to recommend these contract adjustments. Right, now I'm going to present some very simple stuff here, and it's just really for the purpose of how complex the problem is. It was just highlighted. Data are always assumed to be infinite. They're not. Frankly, most corporate managers don't care about climate or water. There is only, in the US, maybe 20% of companies that disclose, and that's a high number. That's just on the S&P, 504 companies. On NASDAQ, it's only 5% of companies. So if only 5% of companies disclose any kind of information, how do we get to 100%? And how do we get to all the facilities of all these different companies? And how do we get from the facilities to the counterparty risk of each of these facilities? And remember, these are public companies. Now, public companies disclose a lot of information, but facilities level information is private. You can get information on Amazon. You cannot get any information on the AWS data center in Jackson, Mississippi. None, zero, nothing. So a lot of that has to come through rule-based learning models and whatnot to understand what that might be. So we use, for example, Bloomberg, the corporate finance and water metrics to sort of develop models to initially start testing and bring them on board and say, well, I mean, this is how we would go to testing robustness and figuring out, I guess, what we think sort of the water intensities are of corporates. And we have both rule-based models, we have black box models, we have GNN models. We start sort of with simple. We start with regressions, with OLS, and then you move your way up from there to say, okay, what can this do for you? What can that do for you? And so it's that's always that next step. Because, and what's the reason why they're so adverse? Well, a pension fund has to communicate information. Pension fund manages money. Pension fund doesn't have money of their own. They manage others' money. They manage U of M's money. They manage other universities' money. They manage individual money. They need to report back to whomever commits their money to them to invest on how they're investing that. So that's part of that thick document that you get in the mail. So a lot of that is this information. How is this real information, or is this imputed information? Is this inferred information? What is it based on? How sure are we about this information? So that's really how we have to bring them on board. So we have to first figure out the non-disclosing firms. And that was easy. That's very easy. I mean, fairly easy. We presented that in New York. In New York, they said, okay, what's the communication back to the companies? Since no companies disclose any information about any of their facilities. So now the CFO or the head of supply chain says, give me a strategy. And we say, based on what? So the first step is there are databases out there, such as Orbis. And luckily here at U of M, we have a lot of access to great databases, financial databases, to the Kresge library at the Ross School of Business, where we can set up, all sorts of, offtake contracts, for data. The Orbis Private Facilities Database, where we have to go from the corporate, Amazon, how many facilities? Mitsubishi, how many facilities? And what kind of facilities? Are these just administrative facilities? Are they manufacturing facilities? Are they suppliers to manufacturing facilities? So that information actually exists. You just got to parse it out. You got to parse it out of this database. So now we overlay that, also the locations. So we can start mapping locations onto risk maps, like these water intensity maps that exist. And this has an interesting story in it by itself. So years ago, I don't know, some of you may recall, Coca-Cola got kicked out of India. And they got kicked out of India because they were overdrawing water resources to make drinks and therefore denying irrigation water for farmers. And basically they kicked them out. So Coca-Cola says, this is not going to happen to us anymore. We're going to look at all 1,000 of our bottling facilities globally and do a full onion layer analysis on regulation, on multi-stakeholder use, on demand, on everything else. So they built up a database, which they then gave away for free to the World Resources Institute in Washington, D.C., and they say, do something useful with this. And to do something useful was essentially a mapping strategy. So the first investors in that do something useful was the Bloomberg Foundation, Goldman Sachs, and a whole bunch of others who have to give out loans to companies that want to build a facility in a certain location. And now because of this map, they know whether these companies in that location actually can access the water for the operations that they need to execute on. So they need to right price that loan. So that we still use that. It's called Aqueduct very appropriately. Aqueduct is the source where you can relay that information. Then, of course, we have to go back to the companies, because companies, corporates, they disclose information to their investors and stakeholders either through 10K reports. These are annual reports required by the Securities and Exchange Commission, or they have their earnings calls. And in those, you now have to start reading in between the lines to figure out how their assets are being impacted. Are the assets impacted through regulation, impact through droughts, impact through floods, everything else? So you actually get information, and we can use NLP transformer models to sort of extract useful information out of these 10K reports and link that up with where we know these facilities are and what they are doing based on the Orbis database. So ultimately, using, again, linkages of multiple different types of risks and type of facilities and groupings and whatnot, and informed learning models, we actually know of any different company in any different location, what kind of risk they are exposed to, the type of risk. Is it a flood? Is it a supply chain risk? Is it something else? And what is the price? What is the value of that risk? What's the impact of that risk on earnings? What's the impact of that risk on operating profit? What's the impact on sales? What's the impact on the likelihood of your facility to become stranded, i.e. no longer productive? So you get sort of all that information, all very indirectly by linking in textual information and financial information and climate information. So we can attribute financial risk to facility scale. So ultimately, actually, what the first client that jumped on us after that was a company called Marubeni. Marubeni just was in the news yesterday because apparently it's a new darling of Warren Buffett. So I'm going to have to take a second look at them. A Japanese securities firm has about 800 companies in it, and they said, all right, Peter, analyze the water risk of all the facilities of all our holdings. And let us know what is the exposure, financial risk exposure that we have in the management of our assets. So any company has different business activities. All these business activities have different facilities. All these different facilities are in different locations. These different locations have different risks and therefore have different financial risk exposures. But when you want to bring it sort of all the way out, when our first point of contact is a CFO or a head of supply chain, he's not going to look under the hood, or she is not going to look under the hood. They want to know the query. What's our financial exposure? Who did what and on what terms? Is our counterparty risk currently sufficiently covered? Questions like that ultimately come out of that complex structure that we've built and are still building underneath this asset. And I want to leave it at this. So what have I learned? Oh man, what have I learned? Well, first off, you don't know everything. Two, you also don't necessarily know what it is what your clients want until you have weekly meetings. I mean, that really helps. When I said, like, look, we know these AI models work. We know these imputation models work. And I said, okay, how are you going to communicate it into these portfolios that you're sending out to pensioners? You can't. That you can't. So you have to sort of really work through that problem. We had to figure out the different data sets that we needed. We had to figure out constraints and rule-based learning and group theory and other types of models we needed to apply to figure out the connectivity, I guess, between different types of risks or the isolation of some risks. We had to figure out how useful earnings calls and public disclosures can be, I guess, to help inform weighting or allocation of these risks globally. We're sort of getting to a point where you can ask a simple question like this, and when you go much deeper, you know, oh, but it's related to these two facilities in Malaysia, that one in Australia, because of this reason. That gives you actionable financial intelligence. And that's ultimately where we want to head. It's the action. Telling people what the risk is one thing they don't really want to hear. It's more about, can you pinpoint it and help us figure out what to do about it? All right, thank you.
Peter, how are you doing reality checks? You can provide this information and you get paid, and they've got to do it, so they got to pay you. But that doesn't mean that your models actually checked against reality. So what was it that you were doing? How many times did a facility go down that you then can...
The whole verification process, you mean? Yeah. So when we initially started doing this and presented this in New York and Singapore and a couple of other places, and people started asking us, well, what is the information you're going to give back to the companies and their portfolio of facilities? At that time, I said, I don't know. We're going to need to get some partners to work with us. And here's a few of the partners that I'm listing. Actually, the very first one wasn't the US, but was Curita. Curita is a food and beverage company. And they said, okay, we're going to give you access behind the firewall to all the information that we have on these facilities. So they became sort of test cases. Then they got, actually, Curita provides water to pretty much every major company on the Nikkei 225. So we got a lot of companies on the Nikkei 225 to actually start playing with us. And they didn't give us all the information, but they would say, okay, what do you know about facility X or facility Y? And we would tell them what our model told us, and they would tell them, well, whether we were right or wrong. And for it, most of the parts where we were wrong is, for example, when a facility was not dependent on a water utility, but they were drawing water from the subsurface or from a surface water or from a lake. basically, I mean, a very different risk than the one that we were calculating. But otherwise, we had our Venn diagram of overlap was actually very decent with these companies. The biggest test now is going to be Marubeni, because they're telling us, essentially, it's a list of stocks. Tell us first the profile. Is it the top 5, top 10? What's the rank order? And out of that rank order of companies, we'll look at the worst affected and start looking at the whole facilities risk using your model. So that's how we can validate.
Start to inject yourself into smart contracting then with those providers?
You got it, yes. So a lot of my research is funded through Ripple. Ripple, a blockchain company. They have a foundation called the University Blockchain Research Initiative, which funds 36 universities globally. Actually, 2 of the original founders of Ripple are U of M math students. So we're one of the 36. I think we were number 27 into that, and they've specifically now said, we want you to be involved in real-world asset tokenization and the blockchain execution of smart contracts, I guess, on all these assets.
Bidirectional information now that's checking the contract and what the performance is on both sides.
More and more. The big challenge, though, with corporates is that, yes, under NDA, we can use their facility level data. We have to figure out yet how to publish that sort of in a sufficiently anonymized fashion, because we can't just use that for free, because it's private information. But yes, we do have bidirectional information to execute on contracts. Yeah.
Very fascinating. You talked about regulation as part of the data information, right?
Right.
Which implies government. If we focus on the U.S., there are certain state and county governments who prefer to put their head in the sand. Right? Climate change is not a problem. We forbid you to plan for it and think about it. Are you building that into the model as a potential risk factor for companies? And then can that feed back to the government, say, we're not investing here because you are blah, blah, blah? Well,
from a corporate, it's a good point. Not explicitly. I mean, that is moving too fast. You know, what's going on in this country politically. But what we do have to calculate in from a regulatory perspective, and business managers are business managers. If these people know that they're standing to lose that one facility can lose $10 million per year because of inadequate, I guess, provision, they're not even going to put their facility there. They're not going to do it. No matter what, whether it's red or blue, it doesn't really matter. If they can get it, it's not going to happen. The thing with the type of regulation we're talking about is really more, is there a cap, or what is the rank order? Let's say there is a drought. A water utility doesn't exist. Water utilities tend to be public assets. They don't exist for the purpose of, keeping companies going. The public is the first recipient, right? So basically, once you start looking at that stratification of demand and order of importance, I guess, as to who gets what first, that is something that we take into account, including the risk pricing. So if you're number 4 on the list, that risk pricing will change versus when you're number 2 on the list. Yeah, back.
Hey, good afternoon. Can you hear me?
Yes.
I actually have several questions, and if I just run out of time, I'll just talk to you after. The first one is so my understanding is, what you presented, this is already delivered to your client, right?
It's already what?
It's delivered, the software package.
No, not yet. No, we're actually right in the middle of this. It's still research, and we have test cases that we are implementing and have implemented. Some of it in a limited way, not the full AI. Is some of it is executed through Equarius Risk Analytics, the company, but most of it is still in the applied research domain.
Okay. Could you speak a little bit about the timeline that it took for your current progress today, and what the team composition was for the for that?
Yes. So don't laugh, but this started probably in 2016 or 2017, a long time ago. At that time, actually, there was because of initial connection then with Zurich Re. Zurich Re, of course, insurance company that underwrites companies' risks. And I talked to them and said, we need to underwrite water risk. And they said, there is no data. So that started in 2016, 2017. At that time, the only people that were in my research group were really a lot more, what should I say? I mean, we had engineers, we had people that knew how to do water resource management. But that's not what we wanted. Because actually, my first interview that I did, not interview, my first survey I did in New York was with Credit Suisse, of course, company no longer exists. And I said, what do you guys care about? Is it in the context of water risk? And he said, we don't care. So why don't you care? A company that's more water efficient versus one that's less water efficient should be more robust, resilient, et cetera, et cetera. I said, no, not necessarily. It depends what this company's risk management and hedging strategies are. So you got to figure out how to turn your physical water risk, i.e. gallons or acre feet or whatever you want to use, into a financial metric. It has to be a financial metric. The Bloomberg terminal in the tail risk analysis, the value at risk analysis, doesn't have a physical metric. It's financial risk. That was the big challenge. So then I actually went to mathematical finance program here at U of M and started recruiting students from that program into my research group. So more actuarial type of background folks. And that really was sort of like a first kind of leapfrog because of their knowledge of those tools where we could connect physical risk and financial risk sort of into bridging that to the next step. So that was probably done by 2018, 2019. Then, let's see, then once we had sort of an initial, I'm going to say tool, we applied that to public companies, so aggregate corporate data, because corporate data is public, we can tap it into Bloomberg, we can get it from Bloomberg. So then that's when I actually shifted, well, I had already shifted my appointment, but I was appointed at the business school, so I pulled a couple of finance folks from there, and they got to work with me on sort of the corporate business model side. So I had the actuarial side, corporate business model folks, and I had the water resources people. So I had already three. I didn't have much of the AI yet. And by then, as I said, that was 2019. And once we started presenting that, then people told us that we needed to sort of provide feedback to companies on how to manage and hedge that risk and price that risk, and that needed to be done within the fence of a facility, not just the data that are presented on the stock market. That's when we figured out, oh, okay, now I'm going to need different skill sets of people that can read, 10K reports and earnings calls and start integrating information like that into all the other financial data that we already had. And so that's where we sort of start slowly bringing in the AI skills and the more of the ML skills and advanced ML skills. And that was, I would say, that was during COVID, essentially. So a lot of that was on Zoom. And that's, yeah. And then the first clients popped up probably 2021, I think. Does that make sense? Is that sufficient resolution? Okay.
I was looking at the tail end, so that makes sense. So the other question I have is, so if you look at like the water contracts, which is like one element of your triangle, so to speak, so you basically have to create some sort of a data set by extracting some key elements out of the water contracts, right? So if we just focus on that, just that aspect alone, did you end up creating one model that can be scaled out to anybody, or is it like customized models for different clients? Because the contracts are very different based on other.
It has to be customized. And it has to be customized because every sector, opportunity cost from risk is very different, for example, for real estate than it is for a data center, than it is for a chemical plant, or than it is for a whiskey distillery, right? So we really had to sort of tailor it at least to sector, if not to individual company. And the way we started it, just very quickly, is that even though we could not get the water contracts that the companies had signed, because as I said, that's guarded as good as, you know, Coca-Cola's recipe, we actually were able to get sort of some differences in contracts that water utilities offer around the world. So of course that has sort of a lot of gaps in it, which is great. But so it has the body language, and even there's much. I mean, as you can imagine, a lot of differences between European and Japanese and other kind of, you know, water contracts. But there is also a lot of filler that is that 30 or 40% that is going to be specific to a specific client. And that we backfilled with the financial information that we had on that client on what that contract needed to be. So is it perfect? Absolutely not. I mean, ultimately, that goes back to the question from the gentleman up front here, is that how do you validate that the water contract that you're actually designing is going to be the one that, you know, will truly help the company? And that is here, this one. Right? How do you know that? That ultimately, again, will need to be, you know, initially through individual agreements with companies to see whether that works, right? So we probably will have separate agreements with, you know, AWS and with Microsoft and with Google and with, you know, Asahi, and which we already have, and all these type of companies, because they're going to be very different. The covenants, the triggers, you know, all the features of the contract are going to be quite, not necessarily utility specific, but are going to be industry specific. And luckily we have a lot of information now on the body of the industry. Yep.
Okay, that is all the time we have for questions for this one.
Question in the back there, or oh, it's all the time, you said. Time's up. Okay, I'll still be around for a bit, so if you want to come, we can follow up with some of the questions. Thank you, appreciate it.